Good morning, everyone. Thank you for coming to my talk. I welcome you at NDC Oslo. Hope you're enjoying the conference. Now we're going to talk about F# language and why it's so suitable for modeling the business domain. So let's get acquainted. Something is not working, sorry. Okay. I apologize, but yeah, it's working. Okay. So my name is Mikhail, and I love F#. Basically, that's everything you need to know about me. Maybe also that I'm a .NET developer for more than 10 years. I don't know, something like that. But let's better talk about you. Who is familiar with F# here? Okay, quite a lot of people. Maybe this talk won't be that interesting for you, since I'm trying to show the beauty of F#, but for others it might be interesting. And by the way, what about .NET developers here? Okay, okay. So many things will be familiar for you. So just briefly about F#. F# is a multi-paradigm language, but with the focus on functional programming. So it's functional first language. More to that, it has an awesome algebraic data type system with pattern matching. I will show what that means a bit later. Also, F# is a cross-platform thanks to .NET Core, or you can use Mono. It's pretty stable, but nowadays .NET Core is the future. Later on, it won't be even named .NET Core. It will be just .NET. And it works on all platforms like Windows, Linux, macOS, even, I don't know, Android. That's great. One more benefit of F# is that it can be transpiled to JavaScript thanks to a project called Fable. So basically you can use F# everywhere, like on backend, on front end, wherever you want. Also, it's a scripting language, so really everywhere. Like F# could be on the server, on the browser, even in your scripts, deploying the build and deploy scripts. And it has an awesome community, really supportive and helpful everywhere. And yeah. So why would I even bother about F# or any other language? Because I'm a .NET developer, and many people connect .NET and C#, like putting equal sign in between them. And C# is good enough for most of us, maybe. But there are some things which are kind of weird for me. First of all, while reading like the code and supporting it, I would like to know what the programmer meant trying to write this code, to design some logic, I don't know, model some business domain. I would like to see the intention. But what I usually get, some uncertainty. Simple example, there is an order service which gives you a list of orders. Maybe not all orders, there is some filtering, but doesn't matter. It should return a list of orders. But what can possibly go wrong? There could be a null, there could be an exception, and you never know. But from the signature of that method, I expect a list of orders, nothing else. It could be empty, right? But it must be there. Sometimes it's not there. Also, nulls, right? So we always need to check for null. Going back to that example, there are There could be a null or exception. Here, we always need to check for nulls. There are a lot of guards, which takes a lot of lines of code. Well, they could be a bit simpler, shorter, but still, only the business logic finally goes somewhere lower, somewhere below, and you need to read through a lot of things. Also, there is a huge keyword noise. Like all those public, static, read-only, void, even class and struct. We all know what that means, of course, like reference types, value types, where they are stored in the memory, and where what is what, and when you need to use that. But quite often we use just class, even for data types, like showing some object, business object. It's just a class, very often with get and set auto properties, which makes it mutable and also not good. That's another thing which bothers me. While reading the code, I see a lot of those keywords, and that hides the real, the value, the logic behind all that noise. Type definitions. I know that's not the best syntax highlighting, but what is that? I mean, what's the name of that method? Oh, yeah, group by, right. But behind all this, how do I find it? Yeah, okay, syntax highlighting helps. Okay, but still, a lot of noise, right? Since like .NET and C# is also not only verbose language, it's also an object-oriented language mainly, like imperative and object-oriented language. We could find some weird naming, like I don't know, that this image could be familiar for you. Imagine indoor session initializer. It's just a door, right? Like, why would we name it that weirdly? Actually, that goes too far sometimes. And we can see something like that. I hope you won't ever see that in real life code, but you know, sometimes we find really, really strange and weird namings quite long. Some of you might say, and what? We are programmers. Like, we need to know, this is our job. We need to know what that means. That's how we make money. That's what differs us from other people. And that's fine. That's fine. I don't think so, actually. I would say there's something wrong. So, while writing the code and then reading it, would be great to write just plain English, right? And just plain English, describe what you want, what you mean, what are the real-life objects you describe, and then just give it to the compiler, and the compiler produces an application. It'd be awesome, won't it? I have an example. While working with business analysts, non-technical people, let's say, not really technical people, and I had a task, like a project, a small project. We had to implement just a simple feedback form on the support tickets, how well the support team worked on that. So there were a couple of smileys. You choose if it's sad or happy, and maybe some comment. So a simple, really simple form, but it had to be done in different languages, like, I don't know, 10 languages, whatever. So we ended up with just a simple JSON file with a key and value for each label, for each string. And I sent it over to the business analyst asking, please fill in this JSON file with just the values for different languages. Sounds simple, right? Sounds like why? Like, what could be easier? If there is thank you, then it should be thank you. In I don't know, in Norwegian, tak, something like that, right? So it's simple, but my request was rejected. I was told that this is code, guys. This is code, and we won't do that. That's your job to write code, and we can provide you translations. Like, how? Like, okay, an Excel file, but again, that would be a table with keys and values. What's the difference, right? So, but even this simple format of JSON format was scary for them. Like that scared people with all those curly braces, I don't know, double quotes, colons. I don't know. For them, it was scary. And everything is different for those non-technical, for business people. It's absolutely different thing. The naming is like really differs. We are used to such names as float. It's nothing new for us, or integer, right? But for them, it's just a number. They don't think in those categories, like float, integer. No, it's just a number. Yeah, that could be. There could be a point, floating point. They would rather call it decimal, if even call it differently than number. Then there is a guide, GUID, right? That's something really strange for them. And even string. For them, it's just a text. If it's a one line of text, then maybe it's line, just line, but not string even. So the conclusion here is that we just speak different languages. Just different languages. They don't use our categories. We could use theirs because we know our domain and we can know their domain. But kind of programmers would say that that's fine. Again, that's fine. We do our job, they do other job. But then we end up with different naming, different naming of the same object, and we sometimes trying to find the piece of the part of the code where we need to maintain and make a change. It's hard because the naming coming from business people is different. So do we have to speak different languages with them? I think no. But then we need probably another programming language. Some so expressive language that you could write basically a pseudocode in comments, uncomment, tweak a bit, make it compile, and then it should work. So that's how F# from my point of view works. Let's see how F# in real life helps us to do that. We can model the domain with just types. There are a lot of different ways to do that in F#. But let's start with something simple, which is a discriminated union, also known as a sum type. For C# developers, that could look like an enum. And here probably it is looks like an enum, but it's not a number. It's not an integer, right? So it's just a type with the value of some name with some label. Very simple thing. It's a currency. Could be either dollar, euro, or Norwegian krone. But discriminated unions can have some extra data. That extra data comes, again, statically typed. So here we have a type weather, and it could be either sunny or it has some precipitation or windy. pay attention to the float with meters per second. This is not a regular float. This is a statically typed meters per second, the speed of the wind. And thanks to C unit symbols, you can use all those all those values from C, all those units from C table. On the bottom, you can see how we initialized values with the type weather. All of them, all these three values, are of type weather, either sunny or some precipitation. The very important word here is or. It can be either one thing or another. So also sometimes it's called choice type. Very simple thing for modeling something or. How would you do that in C#? I don't even know. We can have, I don't know, some interface and implementations of that interface different, but it's not exhaustive, right? So we would be able to introduce another implementation, and how it goes, no one knows. Oh. With those discriminated unions, we can have pattern matching. So it's a simple function. That's how we define a function in F#. Very simple thing. Look, there are no keywords almost. There are no, I don't know, curly braces, no semicolons, nothing really scary. So what you can see is that a function called printWeather expects an argument of type weather. Look, a type weather. I haven't defined it, but it's there. It's statically typed because thanks to type inference. And then there is a pattern matching, which is almost plain English, right? Match weather with something, with sunny. Then print it sunny weather. And then if we match it with some precipitation, which we name P here for like just for brevity, well, we print that weather with some precipitation. So you can see that it's almost plain English. Even here, what could be simpler? I really love that. One more great thing about discriminated union is that it has a way to use just a single case. So here, card number is a type, but it also has just one case with a label card number, which has the extra data of type string, and the card number can be initialized with just card number, and the card number goes then further. Like, while operating with these types, you don't even need strings, integers, floats, nothing like that. You just use card number, which is exactly the same thing which a business person would call it. It's a card number. No one cares that it's a string or it's a sequence of some symbols. It's just a card number, and we all know the format of it. One more type of types in F# is records. Records is a product type. It's a reference type by default, but it's compared by values. So all those equality members are overridden. You don't need them to do that. It's non-nullable by default, and it must be initialized, obviously, and it's immutable unless you just mark it explicitly that it's mutable. Basically, in functional programming, or maybe in F# programming, we tend to make everything explicit. Everything should be visible, right? When you read the code, you don't need to think of, oh, there could be possible a null or something else or exception. Everything should be visible, explicit. Record simple example. This is the definition of a person, and this is the initialization of a person. We initialize a value person with these properties. You cannot define just some of them. They're all mandatory. So basically there is, and let's say, one constructor with all arguments assigned at the moment of initialization. Really simple thing. Again, look, there is type. There is no mentioning of a class or a struct. We don't bother. We just say it's a type, and we know that it's a type. And that's a business object. Yeah, we can make it a struct if we need that. That's possible. But by default, it will be a reference type. This is a combination, yeah, of the discriminated union and records. I believe these can be, it's readable for non-technical people. So the main type which we are interested in is on the bottom. It's payment, basically the payment object, and it can have some amount, some currency, and the method. And you see, there are no keywords here, no programming keywords. Because for a business person, again, the currency is a currency, or amount is a payment amount. Yes, a bit above, we define that a payment amount is actually a type of decimal. But then, in your business logic, you operate with payment amount, not with a decimal. And the check number is an integer, and the card number is a string. But again, you operate with them just as a card number and the check number, as business people would do. For them, it's not a string. For them, it's not an integer again. This is another example. Let's imagine, let's imagine a store which sells some gadgets, and the gadget can have some code. And for example, for phones, it's a string, and for a tablet, it's an integer. But for a business person, again, it's a phone code and a tablet code, and at the end, it's a gadget code. So we end up with the type gadget with a code of type gadget code. Very simple. And we operate these names and categories later on in your business logic. And by the way, you can define your units of measure just with a simple attribute measure, and then you get either grams or inches, which we use for weight and screen size. You probably know the name, not the name, the saying like make your invalid state unrepresentable. So this is how we also do in F#, and that's a great way to approach it. So for different states, maybe even of the same entity or of the same object, we use different types. Let's say we have an order and it has some shipping address, but we don't know if it's real, if it's valid, or if it's just some random address. So before that, before we process the order, when it comes from the user, we just we know that the address is not validated yet. So for us, it's one state of, basically it's a different thing. It's just an order. It's not even a state. It's just a different thing. It's just some input. I wouldn't call it even an order. It doesn't have even an order ID or something like that. It's just an input of a user. So it has an unvalidated address. And there is an order when we already processed validated it, and we now have a validated order. It's a different type. And we can have also a type, which is basically kind of a verb. So it's a definition of it's a signature of a function. Unvalidated address is somehow validated and can output either a validated address or not. So if you remember nulls, here we don't have nulls. A validated address cannot be null. But we need to explicitly say that the value can be missing. There could be not a validated address because the input was incorrect. Here an option type helps. This is a simple definition of an option type. Actually, it's a bit more complicated in the F# libraries, but this is the simplest definition. It's either sum of some type, some real validated address in this case, or none. And we see it immediately when we look at the signature of a method or a function. We see that the address can be missing. The validated address is optional. No nulls, we don't need to think about that. And that's also great. More to that, there is a special result type. Imagine something goes wrong. Like, I don't know, an API is not available, not accessible, database is down, something goes wrong in the workflow. What would you do? Throw an exception? That's usual. But then you need to catch all of them. What if some validation fails? What would you return, a null or something? Result type will help you a lot. So it's either some success or failure. It's statically typed, it's generic here. And if we have a function which takes an unpaid invoice and a payment, it can result either with a paid invoice, if everything goes well, if the payment gateway is ready to answer like everything really okay, or it's a payment error. And that's visible from the first glance. You see like immediately that the result can be either paid invoice or payment error. This actually works with a list of validation errors in this case. The list, by the way, look, it's very simple. Again, it's just validation error list. What could be simpler? How simpler would you write that? I believe for non-technical people, even that will be clear. So there are pretty simple ways to combine the validation errors from separate values into a list and wrap them into result. We won't cover it here. So result with specific success and failure types really helps to understand the intention of the function. By the way, discriminated unions can also be used for different states of the same object. Here we have a shopping cart, which can be either empty or active or paid card, and basically the fields, the values of the fields could be different. So for an empty card, there are no items, right? And for an active card, there could be items, but they're not paid, and there is no payment, obviously. And then again, we can match it, pattern match it, very simply. Match card with empty card, and that's it. We just, plain English, right? So if we want to add an item to the card, this particular item, we match the card with empty card, then we return an active card with just an item in unpaid items. I don't know. For me, that's the simplest way to describe the real business logic. The plain English, almost plain English. And since we're talking about functional programming, we of course use functions and not classes. There are no abstract factories, I don't know, there are no builders, whatever, like all those objective-oriented patterns. Well, of course you can apply some of them, but that's not needed. You can compose all your logic from functions. And functionals are really powerful in F#, since, yeah, of course, it's functional first language. So let's see, starting from the type inference, This is the way I also already showed you, the way we define the function. So we don't write function, we don't write, we don't necessarily write the types for arguments or for return values. It can be inferred from the context, but if you want to, you can do that. The line 6 shows you how to define arguments with specific types. There is no return keyword, as you can see, also one benefit, so everything is clear. The last expression in the function will be the return value of the function. On the line 9, you can see that firstly we define the type of the function, and then on the line 11, we just say that addFloat function is of type addFloat. So it returns a function with 2 arguments, and which returns a float for us. And then we just use the function with just, again, no parentheses, no curly braces, no noise, just the real value, the real logic, the real name of the thing. Yeah, as in previous example, we can just define the types of our functions firstly, and then just have them implemented. Very simple thing. I don't know. I don't see any noise here from my point of view. Like, there's just very neat definition of the parts of the code of the workflow. One more great thing is pipe operator, which can help you to reverse the calling. Like, if you have a function isSum in OptionType, you can pass an optional address there. But with the pipe operator, you can reverse these things, and it will be optional address isSum. Like in plain English. If optional address is sum, then do something, let's say, like a simple example. So with pipe operator, we really use plain English instead of all those parentheses and a lot of parentheses. This is how it helps to compose the workflow, actually. So you can see we have several functions, and then instead of assigning each result of each function to some variable and then pass it further, we don't do that. We just write in the order of execution. So in validated order goes to firstly validate order, then price order, then acknowledge order, then create events. Otherwise, we would need to either put a lot of parentheses around that, or assign each result to a variable, which is not a variable in F#. It's a value. Everything is immutable by default. Oh yeah, actually, here I'm a bit lying to you. That won't work, because as you can see, the return values are results, and the arguments expected are not results. So we need a bit of binding and mapping. But still, if we just look at this, it's not that noisy. And actually, you can define your own operators and avoid this result bind, but just replace it with a simple operator. Someone would say it's even more complicated, like you need to remember a lot of operators. You don't have to, you can use this approach. That's also possible. I didn't show you a partial application. What that means. So all functions in F# are carried, so you can pass just not each argument at the same time. You can pass just one, or I don't know, some just part of the required arguments, and you will get a function back. So for example, if we have a function add with 2 arguments, if we pass just 1, we get a function which expects the last argument, and then we can pass that one and receive the real value. That can be helpful. Partial application is the equivalent of dependency injection in object-oriented programming. So this example is a bit more complicated, but it shows us that we have a function validate order, and it expects 3 dependencies: check product code exists, check address exists, 2 dependencies, right, and 1 unvalidated order. What we can do, we can pass to those dependencies firstly and get another function back. We can even call it the same way, which is called shadowing. And at the end, our validate order function. Oh, here it's sorry, it's a typo. So validate order function is just a function of 1 argument. You need to pass only unvalidated order to it, and that's it. So that's how you, in one place of your application, maybe there's somewhere on startup, you create those functions, passing only dependencies to them, and then you get back the functions with just the final argument, in this case unvalidated order. So partial application is maybe one of the most powerful and important parts in functional programming. Without that, I don't think we would be able to do anything. There is no such thing in C#, and I don't think it will ever happen there. Yeah, so just use F#. You can actually have imperative style in your code. You don't have to use all those pipes, not necessarily. Even here I use pipes just to change the order. But you can see that I just assign values to some, not variables, to values, and then pass them to create events function. That's also possible and could be maybe readable, a bit more readable for people unfamiliar with F#. So if you are starting with F#, probably that's the way to go. And then step by step you apply all those functional techniques. But yeah, you can start with this. Actually, I'm a bit too fast here, but yeah, just to give credit to Scott Floshin, all this talk is inspired by this book. If you read the one from Eric Evans, or if you haven't read the one that domain-driven design by Eric Evans, you don't need that. You can read this book with examples in F#, and that would be more than enough to understand how to model the domain, how to write the domain-driven, domain-specific language in F#, which is probably the most suitable language for that. Scott Floshin also has an article about F#, why it's the best enterprise language. He's the owner of fsharpforfunandprofit.com website. There you can find a lot of examples and a lot of articles how to use F# and in enterprise and not only. There is also an article of F# for C# developers. So feel free to read it. And also I would encourage you to look at the Safestack, which is really great set of technologies for functional programming, for full stack functional programming development, web development. With F#, as I told you, you can write backend and frontend code, so Safestack is really helpful here. And that's basically it from my side today. I'm a bit really too fast, but yeah, that's it. Thank you all for coming, and if you have any questions, I will be happy to answer them. Yes, please.
Question. You mentioned in the beginning using F# on the client side, using Fable.
Yeah.
And there you have a chance of reusing model between server and the client.
Yes.
But of course, on the client side, it's all combined with JavaScript. You are somewhat more limited. Not all definitions will work. So from your experience, how realistic is for complex application to expect that you will be sharing the same model between server and the client? Use F# also on the client side.
Well, you're not that limited, actually. I mean that all those discriminated unions, all those labels are also transpiled into JavaScript, and with some encoders and decoders, like simple JSON or thought, you can use, they are serialized into JSON and back deserialized to the same types and models which you have in F#. So it's one-to-one and back. So I don't see a limitation here, actually. Yes, under the hood, it's JSON, it's JavaScript, so there is no, I don't know, there is even no double or float, whatever.
Exactly. Primitive types, for example.
Well, you can work around them. Again, with strings, and then in F# you would be able to parse them, because Fable allows you to transpile even the framework in the BCL types directly into JavaScript and back. So I don't think it's a huge problem, actually. So you can do a lot anyway. There are limitations, right? But not that much, like not that many. You can. Yeah. With, I don't know, Fable remoting, for example, you can even not write, you can avoid even calling the API manually. There's just RPC style, so there's shared model in a separate project probably, and then you call a function and get that object in Fable in JavaScript or on the server side. It's pretty simple. So I don't see many problems here. So if that's it, then thank you.